Hi guys, greetings to you all. Today I'd like us to look at trigonometric identities. And to begin with, we'll look at Pythagorean identities. Okay, talking about Pythagorean identities, to derive those important results, we'll consider this circle. We have a point here P with coordinates on x coordinates, y coordinate. Then we have the origin. Now the point P here is x units horizontally, y units vertically, and this is the radius. Take note that this point is rotating, is going round. It can be a point, any point on that circle. This is the first quadrant. Okay. Now, how do we derive the Pythagorean identities? From Pythagorean means we use something related to Pythagoras. Let's start by having our trig ratios. Okay, so we have here the angle theta. Sine theta will be opposite over hypotenuse, that's y divided by r. Cos theta will be adjacent divided by hypotenuse, which is x divided by r. And we have this. We equally have tan theta. Tan theta, you know, tan theta is opposite over adjacent. And from our diagram, the opposite is y, the adjacent is x. So tan will be y divided by x. Having obtained this, we will see that this point r, from our triangle here, r is the hypotenuse. How then do we calculate that length r? If you look at the length r using Pythagoras theorem, we are going to have r squared is equal to x squared plus y squared from our diagram, right? Now, when we have that r squared from sine, cos theta is equal to, we have here cos theta is x over r, imply x is r cos theta. So we have here r cos theta, all that squared. Then from sine theta is y over r, implies y is r sine theta. So we have r sine theta, all that squared. And when you square this, it gives us r squared cos squared theta, you square r squared sine squared theta. You will notice that r square is common, so we have r square, we factor it out, we have cos square theta plus sine square theta, that's our r square. And having our r square, you see r square divides through here, we are left with 1 is equal to cos square theta plus sine square theta. So we conclude that our trig ratio, the very first Pythagorean identity will be cos square theta plus sine square theta is equal to 1. equation 1. That's our very first Pythagorean identity. Now from this first identity we can derive other identities, other Pythagorean identities, which we are going to look at. From equation 1. Equation 1 is cos square theta plus sine square theta is equal to 1. Now if I divide all through by cos square, you have here cos square, you have here cos square, divide here cos square theta, this will cancel, we have 1. Now sine square, cos square, we all know that sine square, that's sine theta, means this all that squared. Okay, 1 over cos square, we have 1 over cos theta, all that squared, which have sine theta divided by cos theta is tan. So this gives tan squared theta, and 1 divided by cos gives us secant. So we have here sec squared theta. So this our second Pythagorean identity is secant square theta is 1 plus tan square theta. So that's our equation 2. Now, if equation 1 in a similar manner, we divide all through by sine square. Thus, we have cos square, we divide by sine square, plus sine square all through sine square, and 1 divided by sine square. We have cos over sine. Cos over sine is cot square theta. This is 1. And 1 divided by sine, the trig ratio 1 over sine is cosec. So we have cosec squared theta, which gives us this trig identity, the third Pythagorean identity, that cot square theta plus 1 equal to cosec square theta. It gives us that trig identity. And this is equation 3. This is our Pythagorean identities. So those are the 3 Pythagorean identities. Now, just a few reminders. When in our diagram there, when we say cos, just to remind why stand and the rest, when we say cos theta s over r, and sine theta y over r, if you take, then we say tan theta from our diagram, from our previous diagram, is y over x, right? Now, if you take sine theta divided by cos theta, it means you are taking y over r, right, divided by x over r, which is y over r times r over x. When you simplify, it gives you y over x. What do you notice? You notice that it gives you this. That's to tell us that sine theta divided by cos theta is equal to tan theta. Okay? Likewise, cos theta divided by tan is equal to cot. Take note that we have 3 basic trig identities. We have sine, cos, tan. Now, but 1 over sine has its own name. 1 over sine is cosec. 1 over cos is secant. 1 over tan is cotangent. Alright, I just wanted to emphasize on that because we'll be using them subsequently. And we also, how we are using the laws of indices here as well. You know, if you say a square, b square, for example, is a, b, all that squared. And in general, we say ab to the power n is a to the power n, b to the power n. Alright. Next, we'll look at another identity. Okay, the next set of identities that we'll be looking at have compound angle identities. Now, compound angle identities here means if you have, for example, two angles A and B, that's capital A and B, it is often useful to express as, for example, sine A plus B, cos A plus B, and tan A plus B, for example. Those are compound angles. So how then do we have these identities? These compound angle identities work for the angle, for any angle A and B put together. Like talking about compound angle identities, we have sine A plus B, identity is sine A cos B plus cos A sine B. It gives us the fourth, where A and B are angles. Okay. Then we equally have, similarly, once we know the fourth one, to obtain the next one, we have sine A minus B. Sine A minus B, we simply replace here, so we still have sine A, sorry, this B, we simply have here sine A cos B, okay, minus cos A sine B. That's the fifth identity. So how did we obtain this? If at the place here, when you look here, if you take sine of negative b, sine of negative b is equal to negative sine b. Okay? Then cos of negative theta is equal to cos theta. Alright. So those are the two identities. Then likewise, we have cos A plus B is cos A cos B minus sine A sine B. That gives us 6, which I usually tell my students the best way to understand is that cos A plus B is cos sine sine. So to obtain this, cos A minus B is cos with the minus there plus sine sine. That gives us the seventh identity. Now equally, we have tan. We have another identity, tan. We know tan is obtained by taking, if you take cos, or when you take sine, you take sine A plus B divided by cos A plus B, for example. It means that you are talking about tan A plus B. alright, which is given by our value there, our sine A plus B. Sine A plus B is given as sine A plus B is sine A cos B plus cos A sine B. Then cos A plus B is cos A cos minus sine. Okay, cos minus sine. Now we're going to have something interesting here. If you divide the numerator, we want to simplify this. So when we're dividing through by cos A cos B, so that here we're going to have 1 to simplify it. Note that whenever you divide, so we're going to have sine A cos B divided by cos A cos B minus cos A sine B divided by cos A cos B. So cos A again, since you are dividing through, take note what you do up, you also do down, minus sine A sine B all over cos A cos B, which when simplified, cos B here cancel sine A over cos. We all know that sine over cos is tan. So we have tan. Here cos A cancel, sine B. Okay, we have here sine. Sorry, this one was plus. Sine B cos B gives us tan B. And equally, cos A here, cos A cancel cos B. So here we have 1. Sine A over cos A is tan A. Sine B over cos B is tan B. And this leads us to our very important identity that we have here. So we are saying that tan A plus B is equal to the identity we have, tan A plus tan B divided by 1 minus tan A tan B. So identity 8. Okay. Now in a similar manner, I have tan A minus B. Once you have one, the A plus B, to have the next is always easy. Like if you have sine A plus B, to have sine A minus B is easy because we know we use the property that sine is an odd function. That sine of negative theta is equal to negative sine theta. For example, when I say sine of negative 30 degrees, you will give me negative half. And if I say sine of 30 degrees, it will be half. And when I multiply by negative, you give me negative half. And so we have the sine function, which is an odd function. We have the cos function, which is an even. That is cos of negative 60 degrees, for example, will still be the same as cos of 60 degrees. Then tan is an odd function. As tan of negative theta is negative tan theta. So at the place of positive b, we just replace negative b here, which will just give us tan A minus tan B. And here, because of the negative that we put at b, it will give a positive here. So I have 1 plus tan A tan tan b. That gives us the 9th identity. Okay, having looked at this, we'll look at double angle identities. Okay, to equally obtain the double angle identities, we'll just use these compound angle identities. Like here, if you have a plus b, it means if you replace b by a, we just have now sine a plus a. Okay, so we're having sine a cos a plus cos a sine a, which you see sine a cos a sine a gives us 2 sine a cos a. Okay, so that gets us to, and sine a plus a means sine 2a, so we have sine 2a giving us 2 sine a cos a. Now to obtain that for cos 2a, we go to cos. Here we replace this. If this is replaced by a, we are going to have cos a plus a, which when you look here, it will now be cos a minus sine a sine a. We know that cos is cos a is cos square. So that sets us to the 11th identity. Cos 2a will be cos square a minus sine square a, identity 11. This same cos 2a, when you replace here, if at the place of cos square here, we replace by cos square here, we have cos 2a can equally be, cos 2a can equally give me 2 cos square a minus 1. And it can also be, it can equally be, when we replace here, it can equally be 1 minus 2 sine square a. You see, by using, we are obtaining these other two. These are the other two forms of cos 2a. To obtain that, we know that cos square a plus sine square a is 1. If we replace cos square a here is 1 minus sine square, which gives us 1 minus 2 sine square. That's for another cos. If we replace sine square is 1 minus cos square, we are going to have 2 cos square minus 1. Okay. Then equally for tan, we obtain tan here. This tan a plus b, right? Tan a plus b. If you still replace here, we'll have tan 2a will be tan a plus tan a, which will give us 2 tan a, right? Then you have 1 minus tan a times tan b, which is now become tan a, which is tan square a. Okay, so when you replace there, you have, and that will give us the 12th identity. So the 12th identity here will simply be that tan 2a is equal to 2 tan a divided by 1 minus tan square a. That gives us identity 12. Okay. Hi guys. Before you see, we are going to look at another set of identities called the factor formulae. Please, if up to now you've not yet subscribed, please subscribe, like, share, comment. Factor formulae. The factor formulae here comes in its own form. It comes in the form of the sum of signs, the difference of two sines, the sum of two cosines, and the difference of two cosines. We have already seen double, we've seen Pythagorean, we've seen compound. So don't confuse this with compound. Sine A plus sine B is different from saying that sine bracket A plus B. So what does the factor formula give us? That is sine A is an angle, sine A plus sine B is 2 sine A plus B cos A minus B. Okay. And sine A minus sine B is 2 cos A plus B sine A minus B. That's 2 cos half the sum, sine half the difference. Cos A plus cos B is 2 cos A plus B over 2 cos A minus B. Then cos A minus cos B, negative 2 sine A plus B sine A minus B. Okay. That leads us to the 16th identity. Now, let's look at this example. When you look at this example of this nature, sine 5A minus sine 3A over cos 3A plus cos A, that will prove that is equal to tan A. Now, looking at the numerator, it falls sine A. This is a difference here, so we are going to use equation 14. Okay. So here, sine 5A minus sine 3A all over cos 3A plus cos A. What will it be equal to? We've seen here that we're using this. Okay. Take note that the factor is A. We're using multiples there as well. So sine A gives us 2, they say 2 cos. Here we have what? 5A plus 3A over 2. Right? Then sine 5A minus 3A all over 2. Okay. Then looking at the denominator here, we have cos 3A plus cos A. So we are looking at the 15th. And what does it say? 2 cos 5A plus, sorry, here is 3A, alright. 3A plus A divided by 2. And cos A minus B. So here is our 3A, right? So cos 3A minus A over 2. What does this give for 5A plus 3A is 8A divided by... Okay, sorry, the example to read here is cos 5A. Should read cos 5A. Okay, cos 5A plus cos A at the denominator. Okay, yes. So here it gives us 8 divided by 2, 4. So we have 2 cos 4A. Here 5A minus 3A, 2A divided by 2 gives us sine A. And here this gives us 3A plus A gives us here 4A divided by 2. So we have 2 cos 2A. Here we have cos A. Now looking at this one, because these angles we had cos here, That's a plus b, that's 5a plus 3a divided by 2, 4a. Here 5a plus 3a is 8a divided by 2, 4a. So 2, now you have expressed, you see from that sum as a product of sine and cos. Cos 4a cancel here, we are left with 2 cancel here, we are left with sine a divided by cos a, which is tan a, which is our required result. Okay, thank you. See you in the next video. In the next video, we are going to practice how to use these identities to prove identities. Stay tuned.